In these problems, we are being asked to transform the graphs of some different functions. This first one we've got here is an absolute value function. And what they've graphed is just the basic function, the parent function, we sometimes call it, of y equals the absolute value of x. That is this V shape you see here. And each of the arms have a slope of, well, -1 and 1 over here. Now they want us to transform it to turn it into this thing, the graph of y equals 1/2 times the absolute value of x plus 3 minus 2. And I think what we want to do is take this piece by piece. In these transformations, when you have just a plus or a minus way over to the right here, outside of the parentheses, off by itself, that just moves the graph up or down. When you think about it, it's adding or subtracting to the value, to the y value. So a -2 here at the end is just going to bring this thing down too. So I'm going to do that first. Now, inside the brackets or inside the parentheses, if you've got a quadratic or cubic or something, um, it moves it left or right, but it moves it maybe opposite the way you think it would. If we have a +3 here, it's going to move it 3 to the left. If we have a -3, it's going to move it 3 to the right. So that's a +3, it's 3 to the left. I'm going to do that now too. So we've taken care of this -2, we've taken care of this +3. How about the 1/2? So the 1/2 is going to change the slopes of these two arms. And when you have a fraction between 0 and 1, it makes the function wider, less narrow. So I think we can do that here. And so because it's 1/2 and the base function has 1, it's going to make it twice as wide. So I'm just going to move this out to there. So what I did is instead of it having a slope of 1, I gave it a slope of 1/2. But you might want to check, is that point we put right there, is that really on this new function? And we can tell, it's the x value is -1. If I put a -1 in here, it'd be -1 plus 3, that'd be 2. The absolute value of 2 is 2, and 1/2 of 2 is 1, and then 1 minus 2 is -1, and that's exactly where we are. So I think we've got it, and I'm going to go ahead and hit check. Yep, we got that one correct. Let's try another one. I'm going to skip this one, see if we can get a different type of function. All right, here's a quadratic, and they've given us the base graph of y equals x squared, and they want us to graph y equals -2 times x minus 4 quantity squared. Great. So let's first deal with the x minus 4, because that's going to move the thing to the right. It's inside the parentheses. It's going to move the thing to the right by 4 spaces. So let's just, I need the right tool here, the translation tool. Let's just do that. Okay, so that part is taken care of. There's nothing on the outside of the parentheses, no -2 or +7 or whatever to move it up or down. The only thing we've got to deal with is this -2 out front. And there's really two things going on here. Negative turns this upside down. So this is going to be a downward pointing parabola. And the 2 makes it narrower, it squeezes it in. And I think I'm gonna, let's see, does this turn it upside down? That's a vertical stretch. How do we turn it upside down? Oh, reflection across the x-axis. Let's start there. Okay, now I've turned it upside down, so that's the negative. Now this 2, to make it narrower, you can see with a parabola, you've got the vertex, and then the next point goes over 1, and in this case, down 1. We want it to go down 2 to get this slope of 2 here. So we're going to vertical stretch, and I'm going to move this down to 2. But again, once you've done that, you might want to verify that that point really satisfies this equation to make sure you've got it right. So this is an x value of 5. If I put a 5 in for x here, 5 minus 4 is 1, 1 squared is 1, times -2 is -2, and there I am at a y value of -2. So I think we've done it correctly. Let's just go ahead and check. And there we go. So that's a little bit of work with transforming graphs of some of these functions.